Hi folks, welcome back. This video is going to be focusing on proving this first property we spoke about earlier. Opposite sides are parallel. So essentially, right, we are going to be proving whether segment AB is parallel to segment DC and if segment AD is parallel to segment BC. I will be focusing on proving this first pair of segments, and I would like for you to prove whether the second pair of segments are parallel on your own. Okay, so when we're looking at proving whether these segments are parallel, we can start to think about slope, right? Because we know that the slopes of parallel lines are equal. So basically, what we need to prove here is that the slope of segment AB is equal to the slope of segment DC. And I've written that here just using some notation. So M, whenever you see M in algebra, that refers to our slope. So this is saying slope of segment AB is equal to slope of segment DC. Over here, I've written our slope equation, right? So M is equal to y2 minus y1 over x2 minus x1. The numerator up top is our change in y. You'll know this as your rise, right? And then the denominator is our change in x. You'll see this as your run. So let's first find the slope of segment AB. Okay, so to do that, we need to know my coordinate pairs for A and B. So if you look up at my figure, we see that A is at -4. So A is at -4, 1, and then B is at -3, 3. So I am going to underline my y coordinates here in green. I'll actually box it. And then let me underline my x coordinates in red. So we know that to find the slope, our numerator will be the difference of our y value. So I'll make this one my y2, and then we'll make the 0.8 my y1. So we're going to take 3 minus 1, move it up over, and then since we made this 3y2, we'll have to make this one x2, and then this one here will be x1. So -3 minus -4. Okay, so we've set up our rise over run. Let's start to simplify. So I know 3 minus 1 is 2 on top, and then I have on the bottom here -3 minus -4. Remember, when we're subtracting a negative, it just becomes addition. So -3 plus 4. So this is actually 2 over -3 plus 4 is 1. So the slope of AB is equal to 2. Okay, and we can also verify that by just looking at the figure itself, right? Our rise is just going up 2, so 1, 2, and then our run is just going over 1, so 2 over 1. Okay, so we can actually see when we go from like D to C, that is going to follow that same pattern. We can go up by 2, that's our rise, over 1, which is our run. I'll just take a minute to quickly prove that though with our slope formula. So now that we have found slope of segment AB, we will go into finding slope of segment DC. So in this section, we need to look at point D, which is -4, -5, and then point C, which is at -3, -3. So our slope is going to be rise over run. So my y value is over here, -3 minus -5 over, we have the -3 minus -4. So these are our difference of x values. So we have a negative 3 minus a negative 5 here, so that'll become negative 3 plus 5 over negative 3 plus 4. This will get us 2 over 1. And as we had checked before, it should be 2. So we have proven now that segment AB has a slope of 2 and segment DC has a slope of 2. Okay, so once we go through it and do the second part of this proof, right, if we can prove that AD is parallel to BC, meaning those slopes are equal, then we can prove this first property that opposite sides are parallel, meaning that our figure is indeed a parallelogram.